Alrighty, today we are talking about graphing and functions. The important thing for you to remember is that the graph of a function, any function, no matter what it looks like, is the graph of its ordered pairs. So this particular section we are going to graph ordered pairs and we're going to connect them. Later on we'll talk more specifically about each equation. So to start off with, what you're going to practice is graphing two functions here on the same rectangular coordinate system. They asked us to select integers from -2 to 2 inclusive, so I gave you some charts. And then they asked us to tell them how the graph of G is related to the graph of F. So to begin, when I plug in -2, -2 times 2 is -4, -1 times 2, 0 times 2, 1 times 2, and 2 times 2. So I have the points -2, -4, kind of missed there, -1, -2, 0, 0, 1, 2, and 2, 4. So do your best to get those points accurate, and then you're going to connect them. We can tell that they look like they're in a line together, so we are going to graph them as if they are in a line together. And, poo, that's not what I wanted to do. Uh, Select that color. Do I have the right line color? Let's see. Lines and color. All right, let's try that again. So when I draw my line to connect my points, we have this. Okay, and now I'm going to plug in the same thing. 2 times -2 is -4 minus 3 is -7. 2 times -1 is -2 minus 3 is -5. 2 times 0 minus 3 is -3. 2 times 1 minus 3 is -1. And 2 times 2 minus 1 is +1. So I'm going to go plot those points. At 2, I have -7. Excuse me, at -2, -7. -1, I have -5. At 0, I have -3. At 1, I have -1. And at 2, I have +1. So again, these points appear to be in a straight line. That's not what I want to do. I wanted to draw a line. Take this. I want an arrow on both sides of my line because it goes on forever. And I'm going to pick a color that matches my points. And so when I connect these, then I have something like that. And if you do want to make sure when you graph these that they go through your points. Okay, so they ask us how is the graph of G related to the graph of F? And hopefully you can tell that each of these points, okay, that G is F shifted down 3 units. Now, we're going to talk more about this later. What's important is that you understand that if it's an equation and you create a table of values, any graph you can do that with, and then you connect them to actually graph the equation. All right, the next thing that should be a familiar concept to y'all is talking about the vertical line test. The vertical line test says that if any vertical line, vertical remember is this way, if any vertical line intersects a graph in more than one point, then the graph does not define y as a function of x. So the examples that I have here, what you'll have to do in your classwork, use the vertical line test to identify graphs in which y is a function of x. So you're looking to see, can I draw a vertical line? And actually, if I just go draw one, let's go get one. We'll make it this color. So I'm going to create a vertical line. And basically what I'm doing is I'm looking to see as I cross over my graph here, do I ever touch the graph in more than one spot as I go through here? And you can clearly see that we don't ever cross it more than once. So this particular, oops, this particular um, graph is a function. So we say yes, it is a function. Okay, let's go look at the next one. As I cross over and I draw that vertical line, do I ever touch it more than once? I do not. So again, I have a function. Both of these are functions. Both of these pass your vertical line test. Now when I look at the last one and I go through it, you can see many, many times, but it really only has to happen once. And that is here is one spot and here is another spot. So this one is not a function. All right, the last thing that we're going to do is talking about analyzing the graph of a function. Okay, they've given us a graph that illustrates body temperature from 8 a.m. to 3 p.m. Here is, and notice what they say here. These are the hours after 8 a.m. Okay, and this is the temperature at each of those times. So the first question says, what is the temperature at 8 a.m.? Well, how many hours after 8 a.m. if we want 8 a.m.? That, of course, is going to be 0 hours, so our temperature is 101 degrees. Okay, during which period of time is your temperature decreasing? Okay, everybody knows that decreasing is, this might be a little bit hard to draw because I don't know if they'll let me do this. Decreasing is when your graph is falling. So it is falling from here all the way to there. Yeah, that's what I thought it was going to do. Okay, but you can tell I can't, it won't let me curve on this. Okay, but we have that point right there. So that goes between uh, all of this spot between 0 and 3. So at what period of time is it? If that goes 0 hours after 8 a.m. to 3 hours after 8 a.m. means that it is decreasing. I'm going to go over here to answer B, decreasing from 8 a.m., not to 8 again. Yeah, from 8 a.m. to 11 a.m. Estimate your minimum temperature during the time period shown. So where is this a minimum? Hopefully you can tell this is the point at which it is a minimum. So the answer to that question is, we're going to say it's about 98.6 because I am estimating that because that's what is considered a normal body temperature. So my estimate is about 98.6 degrees. How many hours after 8 a.m. does that occur? Well, that is after 3 hours after 8 a.m. Actually, I didn't write that right. Let's say, to answer that question, it's 3 hours. And so at what time is that? And 3 hours after 8 a.m. would be 11 a.m. So that's answering all those questions. Next it says, during which period of time is your temperature increasing? Okay, increasing means your graph is going to be going up. So I'm looking at this part of my graph. See if that stayed curved. How nice. Okay, so that part of my graph, it says during which period of time. So that's happening between 3 and 5 hours after 8 a.m. So 3 hours after, we already said was 11 a.m. And then whether you want to do 5 hours after that or add 2 hours to 11 a.m. means you're going to go to 1 p.m. Okay? Part E says part of the graph shown is a horizontal line segment. Okay, that's going to be this part here if you can't. That's right here. Boom, that's your horizontal line segment. What does this mean about your temperature and when does this occur? So, what does it mean about my temperature? It's saying that my temperature stays the same. The temp stays the same doesn't change, however you want to say that. Okay, and then it says, when does this occur? So it's occurring at this time, okay, between 5 and 7 hours after 8 a.m. So 5 hours after we already calculated was 1 p.m. and then 2 more hours would be to 3 p.m. And the last question, explain why the graph defines y as a function of x. Okay, why is y a function of x? Because the graph passes the vertical line test. Okay, so I have another example to do in case you want to have another one. When a physician injects a drug into a patient's muscle, the concentration of the drug in the body measured in milligrams per 100 milliliters depends on the time elapsed after the injection, measured in hours. So this figure here shows the graph of the drug concentration over time, where X represents excuse me, hours after the injection. Okay, having a hard time underlining here, my airliner. Okay, there's my X, and Y is representing your drug concentration. Okay, so the key is this is telling you the concentration of your drug, and there's your units. That's how many milligrams per 100 milliliters. So part A says during which period of time is the drug concentration increasing? So let's go try again to highlight that. It's increasing means my graph is going up. So I'm following the graph going up, and it goes up, up, up until this point right here. Okay, why would it curve before? Let's try one more time. Okay, so it's curving. All right, so that is the part where my graph is going up, which is, if I come straight down from that, between 0 and 3 hours. So that answers that question, because they're asking me the time, and we find the time on the x-axis. During which period of time is the drug decreasing? So let's go try. Decreasing is from here down to here. Stop that. Try it one more time. And I'm not really, okay, so you get the idea that it goes from here to here, and I'm just going to try really bad, and it's not going to work for me. So from there to there, which is from that same 3 all the way to, we're going to go all the way to there, which is 13. So we're going to say from 3 to 13 hours, the concentration of the drug is decreasing. What is the drug's maximum concentration, and when does this occur? Maximum is a high point. So the high point, okay, what is that concentration? So that concentration is 0.05. You got to have a units. That's milligrams per 100 milliliters. That's how you abbreviate milliliters. When does this occur? And this would be after 3 hours. So we're answering both parts of that. What happens by the end of 3 hours? I mean, excuse me, at the end of 13 hours. And at the end of 13 hours, this is my graph right here. So what's happening is we say that um, the drug is out of the body because there's 0 concentration. The drug is out of the system, out of your body, however you want to call that. Now, again, the last one, explain why the graph defines y as a function of x, because it passes your vertical line test. So, if you have any questions, please come see me.